You can have a partner that you stay on the same team with. Everything broken?
Sorry.
Okay. All right. So, new competition. This is something we've been designing over the past couple weeks. It's called Cyber Conquest. Basically, it's an attack and defense competition. The way it works, you can think of it like CCDC, where you have your red and blue teams together on one team. And basically, you're defending your network while attacking everyone else's networks. So it's going to be sort of like CCDC. Well, the competition will last 4 hours. We're going to have teams of 6. You can choose your own teams. Basically, the two main objectives: you want to defend your own systems from attackers, and then you want to gain persistence on other team systems. So one thing we're trying to avoid a little bit is just like running in and nuking stuff. So basically, your points on the attacker side are going to be based on, do you have persistence on the system? So the way the environment's going to be laid out, you're going to have 3 Linux systems, 3 Windows systems, and you're going to have a pfSense box that you're not going to have access to. This is basically just to make it easier for us to deploy it. You're going to have access to your Defender systems, sort of like through the mock competitions, through the IA Lab. And then on the attacking side, you're going to connect directly into Project's internal O2 in order to like attack your enemy systems. Because obviously you might not have all the tools you want for on your blue team Defender network. So that'll basically work like how the red team actually connects in during mock competitions. So those attacker systems are also going to be out of scope for attacking, so you're not having to like worry about getting your host computer messed up or your VM or on your host computer messed up by other people. And mainly it's just so that we have like a clear distinction between the systems you're defending and the ones you're attacking. So here's a basic overview of how the entire network's going to look. So we'll have our sort of like, yeah, it'll basically be like our mock competitions. On the left here, we'll have our Defender networks. They'll be behind your pfSense box, and then you'll have your internal subnet with all your 6 systems in it. And then over here, you'll have your attacker stuff, which will connect in, and you'll attack in from this side over there, and you'll basically be defending over there. Okay, so basically the Defender side is going to work a lot like your CCDC mock competitions. So all the new stuff's basically on the red team side. So you're going to be provided with like a set of binaries that you can run on like an enemy system, and then those binaries will try to call back to a scoring engine IP address to like prove that you have persistence on that system. So basically you can run it, you'll give it an IP address, you give it a port, it'll try to call back through that. You can try to do some like proxying stuff. If you want to like pivot through different systems, you can do that. Basically the way it'll be scored is that your persistence will have to call back to the scoring engine at least once per service check. So roughly every 2 minutes should get you what you need. And then scoring. So each system is going to have like 2 or more services on it. And the way scoring works is that points will be generated by your services, sort of like CCDC. But then the points will be split between like the owners of that system and all the people that have persistence on it. So, for example, like I'm on a blue team, my system has 2 working services on it. I don't have any other teams have persistence on my system. Then I get 20 points. System generates 20 points from those services. They get split to me only, and I get 20 points. Then, for example 2, say I have 1 working service, and there are 4 other teams that have persistence on my system. The system generates 10 points, I get 2, and then all the red team people that have persistence on me get 2 points as well. So it gets kind of split out like that. Does that make sense? System resets basically going to be like CCDC mock competitions. You go into the scoring engine, you'll like hit revert. There won't be any point penalty to reverting, but you will have like a cooldown. So you'll get like 10 minutes between every revert, just so you can't revert constantly. So does anybody have any questions about that whole competition?
When would the first competition be?
All right, November 18th. So that's 3 weeks from now. We'll start signups probably like tomorrow or Thursday. We'll send that link out. Yeah.
Is there maybe like a logo or a shield?
I don't know if that's done yet, right?
We're working on that.
We're working on it.
That was really exciting.
You all are going to be guinea pigs.
Yeah.
Hopefully it becomes larger.
All right, so we should have more information like about this in like the next few weeks, but yeah, get excited. We starting with Windows or Linux?
I don't care.
I don't care. Let's do Windows.
All right, everyone. Get your vApps pushed or pulled down and uploaded or started. I can't speak tonight, apparently. Alrighty, so each of you should have a Kali box and a Windows 7 box in this environment. All the IP addresses, username, passwords, all that should be the same, but none of you are connected. So the way we're going to do this is I actually have the Windows box already exploited with persistence on it. And so what we need to do first is go into the Kali box and set up our listeners. So just follow along, especially if you've never done this before. So to log into the Kali box, the password is just the opposite of the username root. So it's TOOR. Then we're going to open up the terminal over here on the left. If you guys want to play around with this later too, I do have a couple files saved for your ease of use. One of those being persistence.txt, which has the command that I run to enable persistence using Meterpreter. And then also meterpreter.rc, which we'll actually be using, as well as the payload that is actually on the Windows system. So the first thing you should do is type service PostgreSQL start. And I'll try and make that bigger here quick. There. That's nice and big. And hit enter. And then after that, type msf console-q-r and then meterpreter.rc. So this will actually just set up your listener for the payload that I already have on the Windows box. That might take a little bit. So at this point, we're going to go back over to our Windows box and open that one. It's Windows 7. And passwords, default password, password1 bang. So just log in. If you go to your Kali box now, it should be set up and you should have this Meterpreter session 1 opened, which is what we want. We want our payload to come back to us. So let's take a minute to talk about persistence and what it is. Who can tell me what persistence is in this whole cyber realm? Anyone? Red teamers?
Just like keeping a shell?
Yeah, so persistence is how the red teamers keep their shell, or they keep access to a system once they've compromised it, right? Basically, what persistence allows you to do, it allows you to stay on the box if your shell dies for some reason, or if they restart the computer, you still get your shell access back. So basically what I've done is I have a payload on the desktop here, payload underscore run as admin.exe. And basically what this does is it just connects back to the Kali box and opens up an interpreter shell so that the attacker can do whatever they want. Well, as defenders, we want to get rid of this persistence, right? We don't want them to keep having access to our system, so we need to find out the ways that the red team puts these persistence mechanisms on the box. And there's a couple different ones that by default with the command that I ran with Meterpreter does. So we'll get into that. The first thing that I always check is Task Manager, right? So if you just right click the menu bar down here and do Start Task Manager. You can check applications. Sometimes there's stuff in there, most of the time not. But then there's also processes, which is where we're more concerned with. So there's a couple things here that you might not always see. It depends on how they exploited the box, but there's a couple that you should definitely check out. First one being this random executable. So if you zoom on that, yours might be named different. I don't know. I think it generates it when it turns on. So you should have some sort of executable running that's just a bunch of random letters and numbers. That is actually our shell. So if we go ahead and kill that by doing end process, on our Kali machine, we've lost our shell. But, as you can see, a new one got opened now all of a sudden on the Kali machine. So what's happened is there's some sort of script or something that's repeating every so often that reopens the shell. So that's their persistence, right? We killed their shell, but they keep getting it back. So we need to figure out what's doing that. Sometimes you'll see this wscript.exe, which is actually what's doing it in this case. There's a script somewhere on this box that we'll go and find that keeps opening the shell up every few seconds. I believe it's 5 seconds is what I set it to. So what you're going to want to do is you're going to want to see if there's any wscript instances running and just end that process. And then we can end our random lettered process. And if we wait a few seconds, we shouldn't get a shell back. Right? So now we've stopped the persistence from the script from running and starting up the shell again, right? But we actually need to go and delete some files off the computer because that's what actually starts it up when the computer turns on. So what we need to do is find out where those files are located. By default, Meterpreter places, oh come on, these in the, it places the script in the temp directory of Windows. So if you type %tmp% into the search bar down here, you can get to the temp folder and see if I can find it. Right here we have a random letter VBS file, VBScript file, right? And this is actually what's doing this. This is the script that gets placed on the system that there's a registry key that we'll go and find next. It actually just runs the Meterpreter payload every time that the computer signs on. So we're going to delete that. And just click yes. Then I'm just going to look around in here and see if there's anything else suspicious. Nothing else looks too suspicious, so we'll call that good. Lastly, by default, the persistence mechanisms that Meterpreter uses installs a couple registry keys sometimes. So we need to open up regedit. So you can do that just by hitting start and typing regedit, one word, right? And hitting enter. And click yes. So it's already open to it where I had it because I forgot to close this earlier. So where Meterpreter likes to put it is in the folder HKey current user. Has anyone played with the Windows registry before? It's a deep, dark place. And it's easy to get lost. So HKey underscore current user. And then sys software under that folder. And then Microsoft. And then we want Windows and run. So this run key area underneath, so it's HKey current user, software, Microsoft Windows, current version, run is the path. This is the key right here that actually tells Windows what file to run every time that the system starts up. And you can see right here, again, it's just this randomly generated string of characters. And then it actually tells us which file it's running to. So you could have done this way first, too. You could have started with the registry and seen the path to the script. But it's C:users DSU app data local temp. So that's the temp folder we were just at. And then a random string of characters. So I'm just going to delete that. And now all the persistence that I placed on this Windows box is gone. So those are the kind of things you're going to want to look for when we're doing our mock competitions. There's a certain red teamer that asked what I was going over today for this talk and told him exactly the things that I was going to be going over, and he's like, screw you, because now I'm going to have to find new ways to do it. So I would definitely look for all these things during our mock competitions, because that's how they do it. Some other things that you might want to check. Actually, let's re-exploit this. So once you've done that, you should be able to go to your desktop, right-click, run as administrator. Click yes. And you should get a shell back. So to interact with that shell now, in order to run the persistence modules again, you have to keep track of this session number right here. So mine in this case is session 3. Yours might be different. But do sessions-I to list any shells you have. And then just check the ID number here on the left. And then you can do sessions-I and then the ID number to interact with it. So in my case, sessions-I 3, hit enter, and I'm in my Meterpreter shell. So the persistence command is just run persistence, and then, come on. I did -u for, so the capital -u, what this does is every time that the user logs on to their computer, that's when you want to run the persistence module. You can also set it to log on every time the computer starts up, other stuff like that. So I'm going to do -I and then 5. So this is telling it to do it every 5 seconds. Every 5 seconds, run the persistence module to make sure that we still have a shell, right? -P for port, 4444. Is the default port for Meterpreter and most Metasploit things. So this is another good conversation to have with this whole persistence and shell hunting thing. If you're watching your network traffic with things like netstat or something like that, and you see something communicating to a remote host over port 4444, you might want to take a closer look at that. It might be malicious. Then I'm also going to do -R for remote address, and this is just going to be 192.168.2.22. So this is the IP address of my Kali box. So there's a lot of useful information for the attacker here, and we just got another shell too in doing this. But important one, it says our agent was executed with a process of ID of 2552. So we'll go take a look at that in a second. It also tells us where our script was stored and the name it got called. So it's C users DSU app data local temp and then something something.vbs. It also tells us where it put the registry key, which again is HKey current user, software, Microsoft Windows, current version, run, and then the name of the key. So as a defender, that's why we want to look for those things, because by default, that's what Meterpreter does, right? So if we actually go look at process ID 2552, that's this cscript.exe now instead of wscript. So that's actually what ran the binary in this case, or the script file. So we could kill that and do that whole other thing, but what I wanted to show is you can also do msconfig.msc, or just msconfig. Oops. Down here in the start bar. If I'm not mistaken, this should show up in the startup section. Yeah. So now if you go into this msconfig program and click the startup tab, you now see we have this new randomly generated string characters, and it's running from app data local temp random thing.vbs and also the registry key. So that's another place that you can check just to get all your paths for your various things that you're trying to look for these persistence modules all in one place. msconfig. So we can actually disable that if we, maybe not. There we go. Just hit the checkbox and click apply. So then now this won't run every time you restart the computer or whatever. It still exists, but it's not going to run. So you'd still want to go and delete that. Or what you should do is you should take a screenshot and use that as reporting, like, hey, we found red team, this was their persistent script, this was all that stuff. That's always a good idea too. Just click exit without restart. We don't need to do that. Final place to check when you're looking for persistence type things is the task scheduler in Windows. So this is kind of similar to cron in Linux, but it's a little different. Quite a bit different, actually. So I didn't actually put anything in the task scheduler, but you definitely should always check it to see if there's anything in there that doesn't look normal. And it should load here in a second. But there should be tasks in here if there are anything. And again, these will run like every 5 seconds, every 30 minutes, every 3 days or something like that, depending on what the red team does. And so you should just go in there and check if there's anything. If there's not, you're probably good. But definitely check those other locations too, the temp folder, the HKey current user, software, Microsoft version, run, startup, all that good stuff. With that, that's pretty much all I have right now. If you do want to play with this yourself, again, come on, in the home directory of the Kali box, I have you just do cat persistence.txt, and you can look at the persistence command that I ran when in the Meterpreter shell. And then if you ever want to just start up your listener, you just do msf console-q-r meterpreter.rc, and you can do that. That's just a file that sets up the handler. And then the payload's in there too, and it's also on the desktop of the Windows computer. And all you need to do is right click and run as administrator. Any questions? Any pointers from red teamers in the room?
Don't do any of what he said.
Yeah, of course they don't want you to do what I just showed you how to do.
Use that, right?
You've you've never used that? I don't think that's true.
I learned that tonight.
You learned how to do it tonight. Oh.
I mean, there totally isn't a poll right now in our chat to murder you.
Oh. I think I'm gonna exit the building on that.
Yes or yes, and the people are voting, so
Oof.
you might need to like get an escort.
Yeah, that sounds like it. Cool. So that's basic. Yeah.
So, is it possible for a red teamer to possibly counter this at all?
Yeah. There's some other things they can do. They could change the default locations where the things get stored, so you'd have to go and find where that's stored. Putting it into the auto run area though is kind of harder to hide because it's going to show up in a couple different places, and then you'll be able to find the paths anyway. But there are definitely things they can do to prevent you from finding the things as easily. So another thing they could do is they could make the files hidden, right? And so you'd have to go change a setting on your Windows system to be able to see the file if you're not in the command line. So, hey, we're trying to make better defenders here, Tristan. Come on. Anything else? Cool. That, I'll give it over to whoever's doing Linux persistence. Is that you, Mike? Or is it Nick? Okay.
What's that?
You like hiding files, Christine?
Okay, so that's got messed up. So this is gonna be more of like an open-ended type lab. We're just gonna like set you loose, and then you can ask questions as we go along, and we'll try to like drop hints over the course of the next half hour. So one thing, so basically the way this works is that we pre-installed a bunch of persistence on the Ubuntu 14 box, and then on the scoring engine is going to actually check that that persistence is calling back. So you can think of that, the scoring engine as the red team, but it's going to show you a nice, pretty scoreboard saying, hey, I have persistence on you. So the scoring engine that we have in here is like a year old, and as such, it doesn't start automatically. So what we got to do is open up the scoring engine VM. If you're going to log in as DSU, password run bang. You type ls, you'll see a bunch of stuff in here. Don't look at it. You'll spoil yourself. So what we're going to do is we're going to run sudo/start.sh. And then password run bang again. And then that'll kick off the scoring engine. And then you can see here, like, this is all the persistence calling back and doing stuff like that. So from there, you can jump over to your Ubuntu 14 system. Has everyone got the like the score engine started up? We good on that? Okay. So you can go to, on your Ubuntu 14 system, you can log in with password run bang as DSU. And then if you go to 192.168.1.2, you'll see the scoring engine like this. You should see like 4 or 5 shells that are red. So basically, if the shell is green, that means that the persistence is still alive and it's still running on the system. Some of them will be red because they're triggered by things that you do. So they might not actually start until you start messing around with the system. So if you pull up a terminal, you should see stuff start to go green, and as you like do stuff, it'll start to go green. So basically what we want you to do is you're going to hunt around on your system and try to find all the persistence that we put in here, and then kill it. And then once you kill it, it should go red on the scoreboard, and then you should be good to go. One thing you definitely want to check out is that some of this persistence is going to be running in memory, right? But it's still going to have files on disk. So there's going to be stuff that I want to run this stuff at boot up. I want to run this stuff when a user logs in, things like that, which won't be deleted unless you actually delete them yourself. So if you kill the persistence in memory, the scoreboard will go red, but that doesn't mean a whole lot if, say, you log out and log back in and then it starts up again. So one thing you're going to want to do is once you get stuff sort of red is to reboot your system so that if there's anything still sticking around in those persistence areas, they'll get started up again. So yeah, I'll just let you go. What you want to look, basically Google is going to be your friend for this, so you're going to want to look for startup locations in Linux, stuff that runs when users log in, stuff that might be triggered, and services, things like that.
After a little bit, we'll probably come back up and show a tool or two.
Yeah, right.
Go for it for a little bit. Does it look to internet access? Does it already get off themselves on?
Pretty sure. Because this is straight from staging, so we would have had to.
I would have thought.
Because we did it last time.
Oh yeah, that's straight from stage. Yeah. I'll be walking around. Oh, you need help there? What? What was the log? It's totally not passable today.
This would be DSU as the username.
Yep.
Oh, you saw it.
I saw that, yeah. Wait, you should complain I can't find something.
Yeah. Yeah, I saw that. Thank you.
It's okay, that's the whole point. You're supposed to look for stuff and overview more nice things, but you gotta cut ahead of everybody else, don't you, Jared?
I started like 30 minutes ago.
Does that mean you're cheating? You got extra time?
It's 192.168.1.2. Should be in your history.
I looked there. I'm not going Jared, how many were down to start? Do you remember the exact number of how many were down to start?
4.
4 were down to start. I don't remember reading that. So we need to run. Yeah. I honestly don't remember reading that many.
Space dot slash start something.
Just run it straight. Is that already operations? Yeah, good luck with that. It's going to give you stupid design about it. Yeah. Just check all those files, Jared.
These are all okay.
Well, we'll get up there in a second. There's a couple tools that will help you out, and we'll go over them, but for the moment, there's tons of shells that are a little bit lower. Yeah, you should probably cancel that. We need to figure out what the options are. Otherwise, it's kind of worthless. I think there's a couple that are a little bit older.
I think one of them has the prop rings.
Oh, does it?
I think so.
I didn't remember how many of those had that. Just one. Just one?
You said you still have the processor.
One of them has a proc ring, yeah. Good luck killing that. Well, that's the whole point.
Yeah.
But I don't remember what that one was tied to.
It's probably the harder ones.
Was it? I don't remember. I thought it might have been tied to the easy.
No.
No, it's just it'd be a waste, right? How many do you have in Jared at this point? You want the you want a folder for it. Scroll around, Google's your friend. You know, figure out some ways to check network connections out, whatever else works.
You're not in a session.
We're gonna have to switch back to the REST API.
For
Everything.
oh yeah.
Probably because just missing too many lines for it to be useful right now.
Yeah, sudo dot slash.
It's like using the HTML5 interface next because it's prettier, right? It's the exact same comparison.
No, I really.
How many do we want to talk about?
We just talk about the process. We just talk about the process. Like looking at network connections. Yeah.
I trust you.
Yeah.
Give another 5 minutes. In like another 5 minutes, we're gonna show you some other tools. Until then. Yeah.
You're not using.
It's not much.
But I just realized.
It should be like. It shouldn't be using default creds, right? For that one? Okay, yeah, I didn't think so. He still has network connections for some reason after we Ironically, we should have labeled these, but that wouldn't have made any sense, of course.
We should have made a table for it.
Well, you know what we could have done?
We did it at the time.
You know what we could have done? When the service goes down, well, that could have caused other problems. It would be a nice idea though, if the service goes down, then it reveals the name, right? But that would cause other problems. Maybe people could just drop a firewall and, oh, they are all revealed. Yeah, that fixes issues.
No, I did other grotesque things too. Yeah, because it's just a name, so it's gonna get crashed. Oh, that's against humanitarian efforts. No, for some reason it's scary. I think I should use that.
Too high level. Oh, yeah. I didn't know these.
Oh, you didn't make a snapshot, no.
Why did I make a snapshot? Hold down, so. Hold down. Yeah,
Just fine.
yeah, I named them. Some of them are named too obvious. Unfortunately.
I mean, Systems 32 is my favorite class.
I know.
I like running that on Start. I found a bunch of them and then rebooted them, so I was like, nah.
I mean, yeah, that's all you did. You go back, you check the scoreboard, and like, oh, look, everything's all nice and
Yeah, I do, when it's sports services.
Nick, you want to show him a couple tools? Kyle Reeves.
Okay, so just like to start out, what you want to do obviously is like look at your network connections. I like LSWF NPI. There's also what's it, NetStat? What do you guys use? TULBN?
I don't remember mine. I had some nice ones, but it wasn't that.
Okay. Yeah, well, I like LSOF. So we'll see that we're running like Apache. We see we're running SSH. We'll see weird stuff like this. So we see we have an SSH server running on port 6554. That doesn't look right to me. So we can run PSOX, and we'll grep for the PID, which is 1018 for me. Is that right? Yeah. So this is going to be a lot harder since we haven't looked at this in like a year.
Yeah. So we made this, but we forgot everything.
So yeah, so we see we have a binary named user bin SSHD, user sbin SSHD. Is that real? I don't remember how this works. So let's look at our init. Actually, let's come back to that one. Let's do something easy. So let's look at SSH keys. So that's something we've been like pushing at you guys like every single meeting. So let's look at our root SSH keys. Authorized. So that's home.sh/authorized keys. And we see in here we have an SSH key installed. So we probably want to get rid of that. And then we can look at DSUs as well, which doesn't look like he has one. And then what you want to do is restart. Actually, what you probably want to do is disable public key authentication.
You were in the wrong directory for the last one. We tried to check DSU home.
Oh.
SSH key in the home directory.
Yeah, DSU.SSH. There we go. So that has an SSH key as well. So we can get rid of that as well. And then just to be safe, let's disable public key authentication. And then we'll restart SSH. Okay. So then hopefully, after a while, that should die. Go away. And so, after network connections and SSH keys, we want to look at like starved locations. So one easy start application, etcrc.local. Oops, that's not good. Oh, I just ran it.
You run the show.
Oh, that's the bad one. Okay.
Oh, cool.
Yeah. Okay, so if we look at etcrc.local, we see we're writing a binary called mail. Seems pretty inconspicuous, but generally etcrc.local will be empty. So you might want to just investigate anything you actually find in here. So if we do which mail, and then you can try doing like a file user bin mail. My network is broken. Okay, so depending on how sneaky Red Team is being, this can either be like a binary like this, which is hard to like differentiate from actually something you installed, or it might just be like a shell script or a Python script or something like that, which is super easy to actually figure out what is going on. So the thing, when you saw me run it, you see like all these PIDs and like random names. So what this script is actually doing is it's like forking like 3 different processes, which are all watching each other, so that when one dies, it just gets restarted over and over again in a loop. So it's like actually impossible to kill unless you reboot. So you'd have to reboot to kill that one. But as like, if you don't know where to look, like an easy thing to do is just to like verify like all your packages are what they're supposed to be. So we pre-installed debsums for you. So debsums is a tool that you can install on Debian systems, which will go through your package list that for everything that you have installed. It will check like file hashes. So go through all your binaries and hash them and check that they match what you are in the list that were like put on your system when you installed it. So you can do that just for binaries, and you can also do it for config files. So if you run debsums-sa, what that's going to do is it's going to try to check every single file it possibly can, and then it's going to be silent about things that are like normal hash, like things that haven't been changed since you installed it. So right off the bat, we can see that debsums found 2 changed files. One is called bin.ls, the other is etc default cups. So we're probably going to want to take a look at those. So I'm just going to open a tab here. Oops. Yep. So if we run file on ls, we'll see that's actually a shell script. It should be a binary. So let's take a look at what's in here. So what this shell script does is it runs another bash, like opens another bash shell, runs this binary called etc DNS resolver, and then it runs your actual ls command like you wanted it to do. So this is basically transparent to you as a user. You type ls, it does what you want, but in the background it's spinning off this piece of persistence that's calling back to Red Team. So now that we know about this, we can just get rid of this file. Oops. So I'll rm ls, and I'll move the hidden file, which is .ls, back to ls. So now I can ls again, and it does what I want. And then just as another bit of cleanup, we can get rid of that malicious DNS resolver. We see this is another elf executable. I want to just delete that. So going back here, you should see like a bunch of other files changing here that you're going to want to investigate. So I'll leave that to you guys. From there, you're going to want to look for stuff that runs when a user logs in, if you want to Google around for that, and then services. You want to look in like normal service stuff, so like etc init, etc init.d, and etc systemd. So I'll let you work on that for a little bit.
That's good practice.
Let's see when he actually died.
If you have questions, feel free to ask. Well, the one you're gonna have to reboot for, of course.
Yeah. I got 2. That's good.
The only way to do it is change the virtual hardware version of this is older.
Yeah,
Maybe
probably
they did
is.
some optimizations at some point. What did you find? MV/bin.ls.
Oh, you can use dir as well.
You can do dirt too.
It's like a backup.
Who needs LS, right? Just use absolute directories.
Not an issue. Jared, how many you up to? Okay, 3 left. So you got 8. So 8's the sort of beat, I guess. We did a couple of later ones. Might be a little bit. Oh.
I honestly have no idea what that is.
What? Which one?
The SSHD running on that high port.
Just check the server configuration file.
In this? Or is that like
No, no,
SES?
the actual server configuration file. It's like SESH. Yeah, like the standard code. Yeah, that one. So all the way bottom for me. Ooh, what did I do? Actually, go back to that other file. Go back to the other one. Maybe I didn't put it in there. Wow, I got elaborate, didn't I?
Yeah.
I am the best red teamer ever.
I know. I can't even stop you.
Oh, is it serious?
Yeah.
Oops.
Maybe not everything.
Ideally not
Not
everything.
everything.
Is it? Wow. Okay. You shouldn't say that loud. That's cheating. We made that up for Cash history. Lol, right?
Yeah.
Or you could go, check. I mean, there's other ways to do it, for sure. I mean, they could do it. They could some pretty, actually, no, they can't. Because they could hash the one binary and then bind it across the system, but they're all different, slightly. Yeah, I think it's in the, I do think it's in the service file. We just have to skip through that one.
got rid of the resistance, didn't you?
Maybe it's a different one.
It could be.
Got rid of it because he can't even use his machine.
Yeah, shit for upstart. I do remember looking at that at least way back. It'd be the start section, right?
Yeah.
I don't know. Can you invoke SSHD as a binary by itself for the port? Spin, I think, yeah. Can you rename that? I don't know if it's my pages or not. Okay, join. You pass it forever.
Thing is, I don't think it actually happened, right? Because that would show up in PSOX, right?
Oh, what do you mean though?
Wouldn't the command show up in PSOX? Because that does, the -D.
You're somewhat right, yeah. Well, so that's just running the SSHD binary by itself. But it's drawing off a different configuration file.
Oh.
So the instance, it's going to be whatever like path was ran in, because it's. I don't know. Yeah, I mean, there's something going on there.
That makes sense.
It's just running off a different, use a different kind of file, off a different path. Don't know how I did that one. Maybe I did jack with the environmental variables. That seems very odd.
I don't think you did.
I don't think either. Oh, ironically, it really does stand out, doesn't it?
Yeah, it does.
Okay. No low balls next time. No low balls. It's not gonna be System 32. It's gonna be RC7.d. Ironically, depth stream is a D very much.
Yeah.
And
Because
that's
it,
actually really good.
yeah. What?
What?
I'm just saying, yeah, because it only checks stuff that you installed, doesn't check new things.
Yeah, but I'm saying that because the list is so small, that makes it really easy to see anything they modified.
Yeah.
So if Red Team wants to do intro, that someone should pick it up. We gotta do that. So, but if they modify anything, that's cheating. DevSums is cheating. There is a alternative DevSums for RPM systems. I believe it's crap, if I remember right.
So I think it's better.
You think it's better?
Yeah.
RPM integrity checking? I don't remember that being better.
And it's more verbose, but
Well, that's not good. That's like, it gives me everything, right? I don't know, you can, I mean, it's later we'll check. Yeah, I mean, I pretty much 777 those, didn't I?
You seen LS of all things? No.
Didn't I Trojan say that? Did I not Trojan say
I think you might have actually.
That's why I was curious, because I was curious why I didn't show that. No, you didn't.
Maybe we tried and then it didn't.
Oh, that's
work.
probably what happened.
Yeah.
See, I think the PAM's wrong too. Like, you want to look at the PAM file given to you by DevSums, because I think it's the wrong file.
Yeah, I think it is.
See, that was what I was saying before, was I thought that it didn't show up right. Because I modified it, but then I didn't. So the other one doesn't show up. That's actually bad. That's really bad.
That's really bad, yeah.
That's insanely bad, yeah. Because they're not going to find that.
No.
No.
No, no.
Jared, you're doomed. There's one we've kind of stated that you cannot find.
I mean, you can find it if you
Well,
look.
you can find it, it doesn't be good. But you gotta know that's not going to happen, right?
All right, let's look at login scripts. So, login scripts at the top level. So, if you look in Etsy profile, this is a script that gets run whenever a user logs in. If we scroll down to the bottom, we can see that we aliased CD for every user to run usershare.hacks, which we'll call back to the scoring engine. So we can get rid of that. And then we can, another thing, if you want to like double check, if you run alias, it'll show all your aliases. And so we can see that alias right here. So one thing you can do periodically is to run alias and then check to see that all your aliases are not malicious. So I'm going to unalias CD so that that doesn't happen anymore. Now it's gone. But that's not all. Etsy profile runs for all users, but then every user has their own login scripts. So if we look in roots directory, we can see we have .bashrc, .profile, yeah, just those two. So if you look in .bashrc, actually let's look in .profile first. So .profile will get called whenever this user logs in. And then one of the things that it does is that it runs bashrc. So it will run this profile script, and then this will in turn run that bashrc script. So let's look in bashrc. So let's scroll down to the bottom, and here we see again we got that .hacks script again. So that alias was in two places, in the Etsy profile globally and in our own user directory. And I assume it's also in DSU's home directory as well. Yep. Oh. And then DSU also has another script. So this is running Etsy shell, which is another callback script. So this will run just once when you log in, whereas CD will run every time you run CD. So we want to get rid of both of those. And then let's check profile just to be safe. Yeah, it looks good. So basically we've done startup scripts, we've done login scripts. Now you want to look at your services, and you want to look at other triggered things. Say things that get triggered when you authenticate against the system.
Unless you want to show that.
Yeah, I'm not sure.
They should know that one.
Which is 7:10. Which is till 7:10.
That's good. So 10, we'll do that one. Then we'll
Yep.
Jared's still stuck at 8.
Why do you say still?
Well, I mean, you were stuck at 8 before, and now you're still stuck at 8.
Yeah, still.
It doesn't like you're not making any progress. There's no movement forward. Which is actually surprising, because I thought this would have been harder.
I think I know what's going on with the SSH.
Do you remember?
I think you put it in a different init script.
Actually, that makes more sense.
Yeah.
I mean, but there's a service. There's like I thought it wrote it straight.
Yeah.
You want to go with service? I don't remember where it's at. You want to check that quick?
Sure. I think I know where it's at.
We can just like a service status all, and then we can sort through that quick.
How about that? Well, that's not it.
I mean, that does something. That's a different one.
Oops.
That's probably what it was.
I don't think it is.
Yeah, well, that's that one probably. Is there one named service? No, there's not. Okay. Yeah. But, I mean, it wasn't supposed to be... That one wasn't supposed to be stalled because you should pick it out when you do the service listing. So, but yeah. Not stalled. That could have been a good service. Or something. They would have probably had a hard time. I thought they would have had a hard time getting it. So, I think the two people I'm going to give is going to be the PHP one.
Oh, yeah.
And the still. But they don't have their. I mean, no, I don't know why they look how they look down. So is Depsum's trash then now?
Semi-trash.
That's concerning. Why does? Because it's not. It's not generated with the package then.
Yeah, it's like in the package it has a list of like Pam has its own sub list of hashes, and Depsum's doesn't like recur.
How do you do that then? How do you check that?
You could do it manually. But
That's terrible. That's what
I don't know.
Can people how easy is it for people to modify dates? It's trivial, right?
Yeah, just use touch. Just use touch.
No, but you can use touch to roll the date back.
Yeah.
Oh, I didn't know that. Okay. Ready to go now.
Okay. So a few last things. Let's look at services. So services are a little bit tricky. Obviously, if Red Team modifies things, that'll get caught with debsums. But if they just add a service into this folder, debsums won't catch it. So you can. There are scripts you can like write up that will actually like go through and find all the stuff that's like been installed and diff it out with all the stuff that's not been installed. But it's a little bit tricky to do. But in this case, it's pretty easy because Michael named it Leet. So if you look in L33T, we see we got Leet hacker scripts here, and it's running etc DHCP DHCP. So we just want to get rid of this. We can just like delete the whole file, and then we'll delete the etc DHCP/DHCP. I don't think there's any other service here, right? As far as you can remember.
Not that I can remember.
Okay. So from there, we have, what do we have left? Like PAM and PHP?
PAM and PHP, that's what, let's cover those two.
Okay. So I can't remember exactly how it works. I think if you go to login.php, we have a PHP shell installed here. So this stuff can be really hard to actually find because you're gonna have a web app that's gonna have like a crap ton of PHP files in it. You're not gonna be able to like sift through all that stuff to actually find these PHP shells. Obviously, we can run LS and things. So what you actually want to do is, like we tell you in the application checklist for web stuff, is to go into etc PHP Apache PHP.ini disable. Forget what the name is. Disable functions, and you'll go through here and you'll like disable system, popen, what is there else? Stuff like that. That's all in the web application checklist. And then obviously restart Apache. Might not even have to do that. We'll see if this still runs. I think it does. Let's look at the actual application checklist. Let's go into training. Okay. Shell exec pass through proc underscore open, and that should be it. I already did that one. Yeah. Restart Apache. And then if we run this, try to run a command, it should fail. Yeah. Try to cat etc password, it doesn't work anymore. So basically our philosophy on the PHP shell is to just disable the functions that Red Team needs to actually like run a PHP shell, rather than having to hunt down the actual stuff, because it's going to be almost impossible to actually do. another thing that is super hard to find are in PAM modules. So if we go to etcpam.d, you'll see a bunch of files in here. So the way like most Linux systems are set up now, they use what's called pluggable authentication modules. And what these are, they basically tell the system how to deal with authentication. Like, how do I check that like this user's password is correct? What other additional checks should I do in order to make sure that they're allowed to use sudo or like su to root? A lot of things like that. You can do like special stuff for like, you can set up a PAM module to say, I want to make people who are authenticating over SSH, instead of authenticating with Etsy Shadow, I want them to authenticate against the database. So you can do a lot of custom stuff like that. So one thing Red Team can do, I think it's in Common Session. Yeah, right here. So there's this crazy module in PAM called PAM exec, which lets you run arbitrary binaries. So if Red Team gets like root, they can add this stuff to the end of like one of your PAM configs, and then every time someone logs in, this pamexec.so gets run, and it runs user share / ... So that's a hidden file that's going to look sort of like going up a directory, but not really. So we just got to get rid of that, and then that'll go away. Unfortunately, DebSums doesn't catch that, because I believe when dpackage installs stuff, it doesn't actually like enumerate all of the PAM configs. PAM has its own little txt file with all the MD5 sums of all their stuff, so it doesn't actually get caught in there. Oh, we didn't go over cron either.
Yeah, that was a basic one. I was hoping we would get that one.
So yeah, cron is like task scheduler. So this is stuff that gets run every time, like every whatever minute. Doesn't look like there's anything in here.
Oh, it's not Etsy cron tab, it's var spool.
Oops. Oh, here we go. So if you do cron tab-e as a user, you'll open your personal cron tab for the user. And then we can see here that we're running Etsy System 32 on that port 7213, so we can get rid of that. Some nasty things that Red Team might do is actually just reinstall cron tabs constantly. So what we tend to do in competitions, which is not necessarily something you want to do in real life, is you like just move all of your cron stuff. So var spool cron to like /temp or root.
Yeah.
Temp's a little bit dangerous because you might lose it.
So don't do that.
And we'll move Etsy cron star there as well.
Someone's just going to be even more careful and move stuff rather than just outright delete it, because it might actually be vital, and it just looks funny.
Yeah. Okay. I think that's everything, right?
That's most of them, yeah.
Okay. Yeah, so if there's anything we missed, I'll leave that to you to find. If I find something, I'll tell you about it next week. But that's all we have. See you guys next time.